Hello there, pre-calculus students. This is Mr. Kashi speaking. This is our video for 9.3. We're actually going to split this up into two videos. The first one's going to just be an intro to probability, and then the second one will be probability with combinatorics. And so I just have a couple of warm-up questions. Usually I'd have you do these on your own. If you want to do them on your own, that would be great. You could just pause the video, do them right now, but I'm going to go ahead and go through these here, A through E. So tossing a head on one toss of a fair coin. Well, hopefully you know there's two sides to a coin, one half. We would say that is either 0.5 or 50%. Our probabilities are either going to be given in a decimal or a percentage, one of the two. Next one is tossing two heads in a row on two tosses of a fair coin. This one might take a little bit more explanation. So two tails in a row, that would be tails, tails. We have to also talk about the other options though. You could have heads, heads, and then you could have tails, heads, or you could have heads, tails. So there's four different options. We're just talking about that one right there. So that would be 1/4 or 0.25 or 25%. Letter C, drawing a queen from a standard deck of cards. Well, there's 52 cards there, and if you're not quite sure, there's 4 queens. And so that would be 4/52, which that would reduce down to 1/13 or 0.0769. So almost basically 7.7% for drawing a queen from a standard deck. D, rolling a sum of 4 on a single-sided on a single roll of 2 fair dice. We're going to get into this a little bit more on how we can do these different sums of rolling 2 dice. Basically, here we have 2 and 2, or you can have 1 and 3, and 3 and 1. So there's 3 options total out of the 36 ways that we can roll the dice. And so that would be 0.0833. We're going to go over a bunch of options like that today as well. And E, guessing all 6 numbers in the state lottery that requires you to pick 6 numbers between 1 and 46. This is hopefully I'm going to help persuade you to make good decisions. So you get one way of choosing all 6 out of the 9,366,819, and that would be 0. Let's see, 1, 2, 3, 4, 5, 2, 3, 4. That's 5 zeros. 1, 0, 6, 7, 6. So if you wanted the percentage, it would be 0.000106766%. So obviously not very likely. That's why playing the lottery is always a very unlikely event to happen, to win that. So that's just a brief introduction. I just want to touch on a few more points on the of kind of reviewing probability principles. We have some good news for you, but it's very simple news that you probably already knew. All of your answers will be between 0 and 1. In probability, that's what it is. You have decimal, you have percent. 0% means that it is it is impossible to happen. 100% or 1, 100% in percentage, or 1.0 in decimals means that it's absolutely going to happen. There's no way it can't happen. And probability is everything in between. So how we would say that is to have 0 is less than or equal to p, which is less than or equal to 1. It's pretty simple when you're talking about probability. If you get a negative answer or you get an answer above 1, it's not a probability anymore. And we're talking about some other type of math. So that should be pretty easy to check your answers. Probability of an event. Basic division problem. This over here at the left is the probability, and F stands for favorable. And so this would be the number of favorable outcomes, and then we divide it by the number of total outcomes. And this can be either, we're going to use decimals mostly because it's a little bit more precise, or you could use a percent. We don't like to keep them in fractions because decimals and percents are a lot easier to compare to one another. So there is a cheat sheet that I'm going to give you. It's going to look like this over here at the right, and we're going to talk about adding these up. So like if you had rolled 2 dice, okay, so this is one die up there, 2 dice over here. You roll them together, and if you were to add them together, so obviously 1 plus 1 would give you 2, all the way down to 6 plus 6 would give you 12. Okay, and so this lays out all the options, and it kind of counts how many are there for you. So you have 6 different ways of rolling a 7, and kind of gives you that distribution right there. So the first problem here is probability of the sum of 2 dice is 6. Okay, well here you can count those up. We have 5 6s right there. So you'd have 5 over, and you have to talk about the total number of ways of rolling 2 dice, and that's obviously 6 times 6 is 36. So that's 5 divided by 36, and that would give you a probability of 0.1389, or that would just be under 14%, 13.89%. Okay. The next problem is we're talking about 2 different numbers. So what's the probability of the sum of 7 or a 9? Okay, so then we're talking about the 7s here or the 9. Well, we have, let's see, we have 6 7s and then we have 4 9s. So then we have 6 plus 4, that's 10 out of the 36. So 10 out of 36, we get 0.27 repeating, or just under 28%. So almost double what we just had with the 6s. And then finally we have the probability of the sum of the 3 or 5. So we have 2 3s and we have 4 5s, and so that would be 6 over 36. And in this case, that's 0.16 repeating, or just under 17%. So just wanted to show you the different ways of the different types of problems that we'll be talking about when we're rolling dice, and how you can calculate them with the help of your cheat sheet.